morning, and welcome to Ampere's annual Roadmap Update. One thing we all know about technology is that it never stands still. Technology waits for nobody. And like a genie, it can't be put back in the bottle. The cloud is following the normal path of a new emerging platform in the compute industry. It started as a new segment, a fraction of the volume, and over the course of the last decade has become the driving force of not only volume, but feature evolution and consumption of performance computing. It has been quite a journey to get to the point in our short but exciting time as the newest CPU supplier in the industry, 5 years strong. I want to thank our customers and our suppliers and the ecosystem that has embraced Ampere and helped us get to this place. In our segment of semiconductors, server cloud performance compute, it has long been served by a single dominant architecture, led historically by a single company. And while roles may be shifting around, the story is the same. A 50-year-old architecture built to deliver performance for a legacy of software that's been built over the past 3 decades. Ampere was conceived of and started to be a modern, dedicated CPU company focused on delivering high-performance, efficient compute to the cloud data center market. The cloud opened a new frontier in defining how modern software is developed and deployed. It's called cloud native. The cloud-native software approach has all been but begging for a new efficient compute engine to power the future and continued growth. The abstraction of software away from the hardware definition, a journey that started a decade prior to Ampere's arrival, has enabled new hardware to emerge without the fears of legacy software's dependence on unique instructions and features. The days of locking the operating system and other software to the hardware have ended. Ampere took advantage of all of the progression in the industry to develop a grounds-up processor that's more efficient in its delivery of the never-ending need for performance across all segments of the cloud data center. We were free to contemplate the features that assist the new approach to software development's performance, and while using an established ISA, we pioneered a new approach with it. Ampere proved out the thesis that the knife's edge of per-core performance versus power is the new quadrant that we all are seeking. On the 2x2 of power and performance, the new normal is down and to the right, lower power but higher performance. And with the birth of Ampere, the efficiency frontier of CPU design has forever been changed. Ampere has delivered on the promise of performance and sustainability. We delivered an environmentally focused, high-performance family of microprocessors that can take the industry further than it's ever gone, to the next frontier of computing, and in a sustainable way. In a world that has no more power, we continue to find ways to deliver performance. This is the mission of Ampere. The semiconductor industry is the enabler of other inventors' dreams. It's what we do. We build things so other people can find answers and solutions to problems we didn't previously know how to solve. So do we collectively think that the last new architecture we will ever have in performance computing will be something that's almost 50 years old? As an industry, we need to stop fearing change, the very thing that we invent every single day, and embrace a future where we don't indiscriminately use power to achieve the performance that our new ideas demand. We need to choose change. The industry needs to choose sustainability. I'd like us to hear from one of Ampere's customers, HPE Enterprise, on their view of the need for sustainability and why they chose to work with our modern cloud-native processors.
When Renee and I began talking about the right infrastructure for cloud-native, in-house, full-stack development, we knew we needed something that would allow the rapidly growing service provider market, as well as digital-first enterprises, to realize the economics of a dramatic increase in a performance per watt. Our customers are excited to have another choice in the industry-leading ProLiant portfolio, a choice that addresses some of the biggest challenges our customers are facing today. For far too long, performance and efficiency have been on divergent paths in the data center. However, with the introduction of Ampere into the ProLiant portfolio, the first and only Tier 1 server vendor to do so, we are now offering an answer to that challenge.
Thank you, Neil. Architectural transitions and change require work. They require focus, execution, and purpose. And they require a conscious choice to change. They happen in our industry every several decades, and it's time again for the next architectural transition. The moment is upon us now to choose a sustainable future for our industry. This change is evidenced by the very fact that legacy CPUs are trying to shoehorn in and label themselves as efficient and for the cloud. It's time for us as an industry to meet the moment and embrace real sustainability and change. Our ability to deliver future performance, it depends on it. I invite us to consider that the future is not like the past several decades of client-server compute. The cloud has ushered in a whole new world, a whole new approach to software development. Isn't it time for the microprocessor to do the same? The world expects us as an industry to do better. I expect us to do better. And today, we're going to introduce you to better. Ampere One. Ampere One is the result of reimagining what's possible in computing moving forward. It's our newest family of products joining our Ultra family. The Ampere One family was created to take the industry forward to the next level of compute, both in power and features, in an efficient way. Ampere One is based on a new core, developed by Ampere. The product scales to 192 Ampere-designed cores for performance while enabling the power efficiency required to meet the sustainability and efficiency challenges of our environment. Ampere One is built from our collective expertise in new core design, product platform design, and unique feature inventions that enable our customers and users to optimize their data centers now and into the future. And while Ampere is a new player in the CPU market, we acquired a dedicated AI capability and team over 2 years ago, and that team has contributed significantly to Ampere One's capability in AI processing on chip. You're going to hear more about this from Jeff shortly. Ampere One delivers the features and inventions that the team has developed for the past several years, putting this product squarely on the path to the future of computing. Jeff, please tell us more about the Ampere roadmap.
Thanks, Renee. At the core of our mission is creating the future of compute, one that is both high performance and sustainable. Because for all the amazing things that the cloud delivers today, sustainability is not one of them. This is the reason we've been building revolutionary products at Ampere for the past several years. Ampere has created a new type of general-purpose CPU called the cloud-native processor that provides maximum performance at extraordinary efficiency. We've taken another big step forward today with our new Ampere One cloud-native processor. But before I talk more about it, I would like to focus on why it matters. Delivering more compute for less power is important in all environments, but particularly in cloud infrastructure today due to the scale at which the cloud operates, and because of the massive impact that an inefficient cloud has on everyone in the world. There's a falsehood in the industry today that increasing compute performance must cost a proportional or even greater amount of power, that there is no alternative approach. We can see that line of thinking today with generative AI, where all available resources are being thrown indiscriminately at fueling these models. A recent industry estimate put the cost per ChatGPT query at 36 cents, over 30 times more than traditional queries. The increase in power consumption is similarly high. The thinking is that if you want maximum performance, efficiency and power are just the cost. However, at Ampere, we have created a new paradigm that the most efficient computing can also be the highest performance computing. In fact, given the scale and sheer enormity of the cloud and the constraints on its future growth, we look at the situation very differently. In the cloud, you cannot have performance without efficiency. Less power is the new power. We created the first cloud-native processor in 2020 by launching Ampere Ultra, an 80-core processor, and quickly followed with the launch of Ampere Ultra Max, the first 128-core processor in 2021. The Ampere Ultra family of products set a new bar for the data center with predictable high performance based on a cloud-optimized architecture and single-threaded cores, extreme scalability across all cores, and a new level of power efficiency, consuming roughly 1 watt per core. We call it cloud native because we built it from the ground up for the cloud. This was a new approach, tackling the problems of a rapidly growing multi-tenant cloud while ditching the baggage of legacy infrastructure. Ampere's rapid innovation continues by building and adding new families of cloud-native processors to meet the range of needs across the compute spectrum, from cloud to the edge and beyond. Without efficient compute, individual cloud data centers, and thereby all compute, will be hemmed in by the amount of available power with no room to expand. Therefore, a sustainable cloud is not just about social and corporate responsibility or cost savings, but about the inherent ability to meet all future compute demand. Unlike the other CPU players who are content with using legacy technologies from the past few decades to maintain the status quo and ignore the impact of runaway power consumption, at Ampere, we are not satisfied with that approach, and you should not be either. Our products are not a derivative of legacy technology from the past era. They are the next fundamental technology for the modern cloud era, one that is very different from the past. Ampere's cloud-native processors not only consume less power than legacy x86 processors, but deliver higher performance as well. They form the basis of an all-around better cloud, predictable, scalable, and secure. Legacy technology just falls short. We are now raising the bar again with Ampere One, the newest member of our product portfolio. Ampere One is about more cores, more I/O, more memory, more performance, more cloud features. With our Ampere custom cloud-native cores, this is the next step in the break from the constraints of legacy compute and our long-term strategy to transform compute for all workloads. No other CPU comes close. It is about cloud scale while providing the maximum performance per rack. We specifically focused on AI performance since AI workloads, especially inferencing, are running everywhere across the cloud. We built Ampere One with up to 192 of our own Ampere custom cores, with new features specifically for the cloud. Our customers have loved the performance of 128 cores and are just blown away by what 192 cores can do for them. Let's hear from some of them talking about the benefits.
We have been able to scale Plesk on Ampere much faster than we ever thought. We generated more than 1,000 instances in less than 3 months. And today, 1 year later, we're actually powering thousands of servers across a Google Cloud, Oracle Cloud, Microsoft Azure, or partners like Hetzner and Scaleway.
A key benefit we've seen adopting the Ampere-based platform has been an improvement in power efficiency. So that's giving us both a cost of delivery and an environmental footprint benefit. And obviously both of those areas are key success factors for us as a company and things that we prioritize. By adopting Ampere, we're seeing a step change, a significant improvement in power efficiency.
Our focus has been on the tail latencies because that's really what drives the customer experience. So we focus on 99.9 percentile and 99.99 percentile, so 4 nines of latency. So we spent a lot of time benchmarking processors, VM SKUs, and so forth across the cloud providers. And what we learned is that the performance on the Ampere Ultra-based VMs has been radically better than anything else we've seen before at the 99.99 percentile latencies, especially when running at high load. And this helps us reduce our costs that we can pass on to our customers, savings to our customers, and it helps us deliver better percentile latencies, high percentile latencies to our customers as well. So they get better cost economics, they get better performance, and Ampere is really allowing us to deliver on that.
As you heard directly from users, cloud-native processors from Ampere deployed broadly from Google Cloud to Oracle Cloud to HPE bring you everything in one product: performance, scale, and efficiency. And that was just the start. Ampere One has been in customers' hands for over a year, and we are in production now. Ampere One takes all the goodness of the Ampere Ultra family and extends it in every dimension to meet the insatiable need for even more cloud compute. Let's dig in, starting with the Ampere Custom Core, built entirely by Ampere from the ground up and fabricated on the 5nm process node. It features 192 single-threaded Ampere custom cloud-native cores, large, cloud-optimized private caches with 64K of L1 data and 2 meg of L2 cache per core. Because these are Ampere's own innovative cores, we created specific microarchitectural Ampere innovations for the cloud, like an L1 data prefetcher with enhanced accuracy, improved branch misprediction recovery time, and advanced memory disambiguation. All of these features are tailored for high-performance, highly utilized, multi-user environments like the cloud. The core design focuses on power and area-efficient IPC gains, delivering the best performance per rack in the industry. And in AI, an area Ampere already excels in, Ampere One has two 128-bit vector units per core, plus bfloat 16, in addition to existing native int8, int16, and fp16 support. The result is the most efficient and highest performance core in the industry for cloud workloads. We have also introduced new cloud features in 3 fundamental areas: performance, manageability, and security. To deliver performance consistency, we introduced mesh congestion management, which improves performance by managing traffic across our dense 192 cores. Memory and SLC quality of service enforcement, which manages cache and memory usage to ensure consistent performance across many users. And nested virtualization, which creates new functionality in IaaS environments. For scalable management, we have created fine-grained power management, which allows more visibility and control to users over how they manage processor usage power. Advanced droop detection that better monitors voltages, saving power. And process aging monitors, which assess processor stress over time, extremely important in large-scale cloud environments with sustained heavy usage. And lastly, for cloud security, we have added secure virtualization, which provides additional methods of isolating workloads in a multi-tenant environment. Single key memory encryption, which protects memory from being maliciously read by unauthorized actors, and my favorite, memory tagging, which both prevents a class of potential attacks that use buffer overflow as an exploit and improves application data integrity for usages like databases. This is a key example of a feature that is not anywhere on the legacy horizon. With 8 channels of DDR5 memory and a 12-channel platform on the way, plus 128 lanes of PCIe Gen 5 I/O, we are scaling the entire platform. This is a killer product. Our expanded product portfolio, including the Ampere Ultra and Ampere One families, scales to your needs, from low-power edge use cases in extreme environments to the densest cloud data centers. Both Oracle Cloud and HPE have been delivering our processors to their end users and have tackled a range of use cases. Let's hear more from them.
Oracle was the first cloud services provider to globally deploy compute based on Ampere processors. Since then, we've had amazing results from customers all over the world, including Red Bull F1 racing team, who found their number of simulations increased by 25%, with improvements to accuracy of their predictions and sharper decision-making. Additionally, we reduced the cost of these simulations, enabling them to be a much more cost-efficient team. Finally, Matoa, who's a UK-based startup using its scientific and engineering expertise, the company developed low-cost handheld scanners that can easily identify plastics or fabrics anywhere and anytime. They selected OCI and Ampere Altra A1 compute instances to train its ML algorithms in the cloud and found 2x lower latency and price performance with a whopping 75% cost savings compared to other processors.
We brought the HPE ProLiant RL300 Gen 11 to market, and we've been delighted by the customer feedback that we're receiving from the numerous customers actively deploying and evaluating the product. One European SaaS provider told us they saw significant improvements, not only in performance and in price performance, but critically in performance per watt. A web hosting company in the United States tells us they saw such great price performance results that they're now able to offer a lower price for their service and compete more effectively. I could not be more excited about the strategic relationship between Ampere and HPE and the opportunity we're creating together for our customers to realize breakthrough value and efficiency.
Wow, this is a massive shift across the entire industry. Remember where we started. Legacy CPUs from Intel and AMD have suffered from major shortcomings in the cloud. They were architected before the cloud era even began, so they are unpredictable in multi-tenant environments. They cannot handle high utilization, and they even have client features that expose security vulnerabilities. But the worst problem is the inability to continue scaling compute performance within existing power and space constraints. This impacts everyone. Whether you deploy your own hardware, run your software in the cloud, or you're just concerned about global sustainability. Boiling it down, we call this problem the performance per rack barrier. Let's look at an example. If you have a web page or an application that needs to service a high number of user requests per second, you would like the most efficient and lowest cost way to do this while also meeting all your users' expectations. Your data center or total compute installation is likely made up of hundreds or thousands of server racks, each a standard size with a certain power capacity. When you run out of space or power, you cannot add any additional servers. Thus, the amount of compute you can deploy in a rack is a fundamental constraint. This is the performance per rack barrier. This is a real-life problem that I have personally seen in countless data centers around the world, characterized by half-empty racks and continued data center sprawl, with more and more power consumed to meet growing compute demand. If you're not already seeing this today, you will soon. And unless you take a different approach to the CPU, your total capacity per data center will actually decline over time. In this example, to meet your user web requests, you would start with adding servers to your rack. With Intel Xeon CPUs, you would quickly run out of available power and need to move to a second and even third rack before you could serve all users. Intel has hit the performance per rack barrier. With AMD EPYC CPUs, you would run out of power in the first rack and move to a second. Again, now AMD has hit the performance per rack barrier. However, with Ampere's cloud-native processors, you can meet all user demand in just a single rack. By delivering 2.5 times greater performance per rack, you have broken through the barrier and will consume 2.8 times less power with 1/3 the data center space. And that's just with today's Ampere Ultra family. With Ampere One, we extend this lead even further for those requiring extreme performance and scale. Let's start with a simple example that is common across the cloud, running VMs. With Ampere One's 192 cores versus AMD Genoa's 96 cores, or Intel Sapphire Rapids' 60 cores, Ampere One runs 2.9 times more VMs per rack than Genoa, and 4.3 times more VMs than Sapphire Rapids. Intel's not even in the ballpark, and AMD lags far behind. Now, let's look at a real-life cloud workload. AI applications are the fastest growing within the cloud today, so delivering the most performance and performance per rack in AI is a must-have. Recommendation systems that suggest the next video to watch or the best product match for your search make up a large portion of this AI compute. They typically have extreme data loads and require rapid transactions for the end user. Instead of throwing incrementally more resources at the problem with legacy technologies, imagine being able to deliver 18.9 million recommendations per second in a single rack with Ampere CPUs running the entire workload. That is over twice what AMD Genoa can deliver. Elsewhere in AI, generative AI has taken the world by storm, and Ampere One beats AMD Genoa with 2.3 times more performance per rack in the popular Stable Diffusion model that generates images from text prompts. Ampere One was specifically designed to deliver amazing AI performance in an efficient manner. This is game-changing. We are not alone in recognizing this need. Intel and AMD are taking note, but this is not about merely adding a derivative product line using the legacy ingredients that happen to be lying around. Ampere believes the cloud requires a fundamentally different approach. It is about building for the cloud versus building for legacy, and certainly not about legacy pretending to be cloud native. As all compute moves to the cloud, the entire platform must be cloud native, from the applications to the processor. This is a complete reinvention from the ground up, and it's happening everywhere, leaving legacy x86 CPUs in the past. The Ampere Ultra family is the workhorse of the cloud data center and edge, leading all other CPUs in market in performance per rack, including AMD Genoa and Intel Sapphire Rapids, with the lowest total power footprint. It is available and deployed at scale today across major hyperscalers, with over 50 server and edge platforms already in market using proven DDR4 and PCIe Gen 4 technology. The Ampere One family delivers maximum performance and scale for the most demanding deployments, extending the performance per rack lead with up to 192 cores, DDR5, and PCIe Gen 5. It has the highest overall performance, scalability, and density for cloud workloads. It delivers new cloud features for better performance consistency, scalable manageability, and security. No one could ignore the urgent need for efficient compute at scale. Ampere is leading the way. If you build your own cloud, you can run at high performance and utilization without needing to build new data centers, procure more power, or overhaul your infrastructure. If you run in the cloud, you will have an exceptional experience and be able to scale to higher performance with more cores while using less resources, both power and money. If you develop cloud-native apps, you're going to love this. Our cloud-native processors run and scale the way your applications do. If you're just a beneficiary of all the goodness of the cloud, running apps on your phone, watching streaming videos, or exploring the amazing AI breakthroughs from GPT, you can feel good that with Ampere cloud-native processors, the cloud you use is sustainable. The choice is clear. Innovate today with sustainable cloud-native processors from Ampere. Better performance, lower power, a more sustainable cloud.
Time is not on our industry's side relative to the power demands of data center computing, with the growth of AI, of connected everything, and our insatiable demand for streaming media. If we continue the path we are on, using legacy CPUs and even higher power-hogging GPUs to power our growth, we'll not only run out of the ability to power our future, we're also destroying the environment along with it. Consider this. Every data center that's built with Ampere performance-efficient, sustainable processors is like taking 39,000 gas-powered cars off the road or powering 35,000 homes. I want to challenge each of us to have the courage to follow our intuition and embrace the change that is needed in computing to push our industry forward to a new quadrant of compute. High performance at lower power. We need to choose sustainability. The rest of the world will thank us. We need to be the change we want to see in the world.